this series is a part of a broader series I'm doing on data structures and algorithms. And data structures and algorithms is actually at university, not an atypical class to take at all. And so what it is it's an opportunity for you to kind of think about how you can structure and store data on a machine and search through it frequently, manipulate it, store it to kind of get optimal outcomes. So that's the purpose of data structures and algorithms, and that's kind of the thought process behind it. So a linked list, there's different ways of storing data. Anjali, you're a software engineer. Don't give too much away, but what are some structures that you can use in Python or other coding languages to share data? Or to store data is what I mean by that.
But yeah, it's basically like it has the elements where you call them as a node and use them as a pointer, right? Rather than like just being stored in a memory, like arrays or stuff. But yeah, I think that's the basic idea of it.
So okay, so there's some good stuff in there. Let's think of it in a different way. So basically, we can start. How I'm actually adding this slide. I'm kind of doing this impromptu. So if I'll use this. If I want to store some data in the machine, what I basically have to do is here's my computer memory, and a chunk of that memory, of course, is going to be stored. Is going to have other processes, like the operating system is going to be in my memory. Let's actually forget the operating system because we're not really talking about that here. We're talking about whatever applications I have running on my machine. Those are going to be stored in my memory right now. So some percentage of my memory, the orange is like my machine's memory, and this is my other applications. Okay, this is taking up half of my machine memory right now. So my application opens up, and in my application, or in my data analysis project, it works the same way, David. Whether I'm writing a program or I'm doing manipulation, when I create a variable in Python, when I say x equals 2, there is a space that my machine reserves in memory. It's probably tiny for something that small. It'd be even much smaller than this, right? But and then it basically takes up a chunk of the memory and says, okay, this memory is now, we refer to it with this variable name x, and we and we've stored the number 2 in there. Obviously, it's a little more technical even than that, like what is x and 2 in computer language, but we don't care about that for our purposes. So another option, if we want to have a set of data. So x is 2 is kind of one option. So this is the option I have over here. The other option, let's say, is not option, but in Python, you have a data structure called, for example, a list. So in JavaScript, this is called an array. In C++, I shouldn't say it's called an array, but yeah, they have arrays in C++. They have arrays in Java, and so an array is basically a set of numbers. So, or it doesn't have to be numbers. It's a set of data. So it could be, it could be Joe and Jolly, David and Melina. That could be my data structure here. Okay, so this is an array. So and the reason maybe I have it structured in this way because what I have here, I have like a favorite colors application. And so, Grebe. So in this, David, do you remember what zero indexing is?
It sounds familiar. I don't remember what it is. It might have occurred to me before.
No, I'm sure it has actually. I was like that. So there's an idea in computer science that we zero index things. So we basically, if I say this array sub 0, I'm actually referring to Joe. And then the first element's actually in Jolly. The second element is David, and the third element is Melina.
On Python, I did see something like that.
So instead of starting with 1, we do the same thing that Europeans do with the the floors of their buildings, where really they enter on the 0th floor. In Europe, they'll be like, you've entered they don't count, they call it the ground floor, and then you climb a set of stairs to the 1st floor. So they zero index their floors in Europe, just like we in computer science zero index we zero index arrays, essentially, or lists. In Python, it's a list. And what an array is it's a data structure that basically says I enter into computer memory and I block off a hunk of memory. And I say I want it to be 4 units long, 4 elements long. I'm going to have 4 elements in this. And so they can initially be 0. In Python, we actually don't have like an array as a native data type. We have a list as a data type, so you don't actually have the disadvantage of having to pre-specify the size of it. But basically, in an array, I would say, okay, I'm gonna have 4 elements in this array. So you instantly, when you create the array, block off a hunk of memory equivalent to 4 elements. And then when you want to access those elements, what I do is I can say, give me, let's pretend we name this variable my array. I can say, give me my array sub 2. And that gives me David, or if I say the favorite colors, it's green. Or if I say my array sub 3, then it gives me Melina or yellow, depending on which array I've called. If I've called the colors array sub 3, then I get yellow. If I've called names array sub 3, I get Melina. So that's kind of how that works. The next thing I kind of want to add to it. So that's what an array does. It blocks off a hunk of memory, and then I essentially have the ability to access in relatively quick time an individual element of the array. Okay, so that's kind of the idea. So a linked list functions a little bit differently. Okay, let's stick with the array. Actually, what I'm really getting at here, I said array here. What I actually mean is list. So let me change that to list.length. Okay, so there's a couple of things to mention here. So right now I have a list in Python that has kind of 5 elements. Okay, so a list in Python is delineated, and we're going to code this up together. And actually, we could even do it now if you wanted. Let me get that IDE. I have an IDE. Just give me 1 second that I was intending for us to work on together. I will share my screen so you can see this. If you open the chat and click that link, then you can kind of do this along with me. So now we see this Python IDE. This is just the default thing that came with it. So the point I just want to make, if you're not a Python syntax expert, no worries. I don't know what you guys code in, but let's say I wanted to make those exact arrays. I actually will copy and paste it out of this code. So we'll say names is equal to this, and colors is equal to this. Hold on 1 second. It's not recognizing these as strings yet because these have to be redone with these other quotes. Sorry. PowerPoint automatically makes your quotes squiggly so it looks prettier, but then Python can't read it anymore. So they're not meant to, most people aren't transferring their PowerPoint code or their PowerPoint text into code editors afterwards. So, okay, sounds good. And then basically if I were to print this, I mean, this is pretty simple, but if I say names sub-0, I'm going to get Joe, and then if I say color sub-0, I'm going to get blue, right? So if I run this, hoping I'm not going to get a surprise for doing something wrong. Oh, I am. Sorry about that. This does not have a close bracket. Stop. Is there a second syntax error here? I don't think so. Okay, so then I get Joe Blue. Okay, so that's all we've printed here, but this is just going to give you a demo of how the array works. Okay, so in an array, if I want to now add an additional, element to my array here, all I do in the kind of traditional array sense is go ahead and add it to the end. right? I can just add it to the end. So, well, excuse me, that's not the traditional array. That's a Python list. So actually in a traditional array, you don't have the flexibility to in the actual array, which is you actually have to start with a fixed length, and then you don't have the ability to adjust the length later. So when people actually talk about true arrays, like we use the term array in JavaScript as well, but it's not truly an array because you can adjust the size, for example. But in most of the time that wouldn't be the case. Like an array in C++ means that you can't change up the size, for example. Okay, I'm gonna hop over here because I thought I had a little thing to make it a little easier, but that's okay. I'm gonna do.
So I would like to add something in there.
Please.
Yes, you're right. So you cannot add it in the same array, but if you wanted to like create a new array and then access from that, you are able to, but just like adding is not possible on the same array. So if you can create like the separate array with the different name or the similar name, then that's just going to reserve like the different memory, but you can't just access from the same array. I mean, you're saying it right, but it just like, I just wanted to add that it's doable if you're going to create different array for that one.
Got it.
That one.
Okay, sounds good. No, thank you. That's fair. Of course, it's doable. So the point of data structures and algorithms is to mostly think about what are the things that we want to kind of adjust, or like what are the things that we want to kind of demo or build such that our code runs in the most efficient way possible. So let me jump forward to the linked list really quick then. In a linked list, what a linked list does, it contains two things. A linked list contains essentially what are nodes, okay? So it's just like different various data structures. One of the big things that we explore in data structures are combinations of data that go in a specific order. We have linear data structures. Linear data structures are things like stacks and queues. And a stack, for example, is something that I have this. When an element comes in, if this is a stack, for example, when an element comes in, I put it there. When another element comes in, I put it here. When another element comes in, I put it here, blah, blah. And it kind of keeps going like this. So we stack it up. Actually, usually you think of this horizontal because we kind of assume that gravity is gonna hold this down. Okay, that didn't look quite as nice, but if you rotate this mentally 90 degrees, you've got an element at the bottom. This bottom is kind of fixed. Or if I have a stack that I put coins in a stack, I add one in, I add another one in, I add another one in, I add another one in, and then when I want to take one out, I take the top one. So it's called a last in, first out data structure. It's a last in, first out data structure, and that's because the last one that you put in there is the last one that gets taken out. I do think it actually is easier to visualize with kind of this way. When I add something to my stack, when I add an element to my stack, it's now the top one. And then when I take something off my stack, I take the top element away from it. So that's what a stack is. Okay, are there any questions on that? Is that clear? A queue is what's called a first in, first out data structure. So it's kind of like, let me just label this a stack. Okay, so here we have a stack, and here we have a queue. There's more to say about each of these. Like there's also different verbiage, like queuing. So stacks, I think you pop, if I'm not wrong, and queues, you enqueue and then you dequeue them, but it basically means add and remove an element from it. So a queue actually kind of works this way. When I add, so my queue is initially empty, and then I added an element. This is element one. We'll get rid of these for now. Let's set this aside so I can use it later. Okay, then when I get an element 2 coming in, this one kind of gets pushed to the right, and now element 2 comes over here. If you think of it horizontally, it's the same idea. The second element comes in over here. Okay, and then the third element, so I add another element, it's a queue, because queue is literally the British word for a line, like when you're waiting in a line of people. And so when you're waiting in a line of people, if you're the first one in, you're the first one out. And so that's why it's called a queue. And so here, as new elements come in, this is where they enter down here, and then they exit essentially when they, if and when you take elements from the queue, remove elements from the queue, the first element in is the first one that goes. And again, that differs from the stack, because if I'm piling up a thing of coins or a thing of plates, when I take plates out of my dishwasher, the last plate I used is actually the plate that gets used the most, right? Because I put it on the top, I take it off the top. I put it on the top, I take it off the top. Whereas a queue functions like a line when you're waiting for something. So that's what a queue is, queue and stack. Okay, so that's kind of like we have to kind of make these choices in data structures. Like, how is it we want our data to react? So a linked list is neither a queue or a stack. I mean, you could use it for either one, right? But that's neither here nor there for now. A linked list, the way a linked list works, basically, each element in the linked list contains two things. They're called nodes because it's kind of like a chain. Your elements are called nodes, and they're linked essentially, meaning that rather than like an array where I would just say, okay, I want array sub index 1 or array sub index 2, I would say you start at the first element, and each element contains at least two properties. The basic logic is it contains two properties. The first property that it contains is the data that you want it to contain itself, right? So it contains the data. So let's say we need something that's kind of ordered. So let's put our names in alphabetical order. So the first one is Anjali. Okay, so this first piece of data that this first node contains is Anjali. The second piece of data is it contains information about what the next node is. So from this node, we actually link directly to the next node. And that's why it's a linked list. So each node contains the data that it actually needs, as well as a link to the next node. And so this essentially works the same way, where this next one, I add a new element and I say Joe, and then it contains a link to the next node. So in this case, then this one will contain, the one I didn't add Joe, I added David. And actually that I made that mistake is important, and I'm glad I did, because we're gonna take a look at what that means if you make that kind of mistake. And then the last one is Melina. So if I'm traversing a linked list, I start at the beginning, and I'll say, okay, like I'm accessing this data structure. A data structure, again, is something that basically holds and organizes your data. And so I enter my linked list. I enter it essentially the first node, and I say I'm looking to see whether a student named Robbie came to class. Because these are alphabetized, I start here, I traverse through, and I essentially hit the end in this context because the R is after the M. You could have conversations about how you want to structure that, but and I say, okay, no, nobody named Robbie came to this class, for example. So like that's kind of the idea. So I would start here, and it points me always to the next node. If this is the first time you're looking at data structures and algorithms, the question I'm about to ask is you're probably not even going to understand what I'm asking. But hopefully, as we talk about it, you'll get there. So but I'm going to ask Anjali or Melina. Melina, are you a software engineer?
No.
No. Okay.
I have a bachelor's on engineering.
Okay, very nice. In computer engineering or software engineering?
Neither. Geological engineering.
Okay. No expectation of knowing anything about data structures then. No expectation. Sounds good.
I took MATLAB.
Good. But that's good. But that I would not expect you to have any knowledge of data structures then. But that's great. I'm glad you're here. Anjali, can you think of some advantages or disadvantages of linked lists in this kind of structure that we talked about right now? You've seen other data structures, so you have some kind of point of comparison potentially for linked lists. So that's why I'm asking you, Anjali.
So I mean, if you wanted, so there's like two kind, right? So it's a singly or the doubly, or I think there's like a circular or whatever. But if you're using like this single link list, so that's basically gonna look through each, if it's alphabetical order, like however you have kind of done it, and then it's just gonna return like zero for you. What if like you just added another and it's not gonna like look it through? So that's kind of like the disadvantage. So it's not gonna go to like, it just pointed to the next node. It's not gonna go to previous. But if you're using the doubly linked list, then it can like just traverse through both and then kind of like look for the first node and then the last node. So that's one of the advantage. So overall, like the linked list advantage is you can always add node to it. So that's better than array, that you don't have to create completely different array into it. So you just basically can add one node and then point to that. But yeah, disadvantage is like if it's just going through in one line, and if you just added node, you might miss that. I think that's what I remember, but I don't know.
Okay, so no, this sounds good. Thank you, by the way, and I appreciate your point, Anjali. So we here are taking a look at a singly linked list. That's what we're going to look at today. That's a good point, because there is doubly linked lists as well. But I think for our first time, this is terrific. So the first thing I want to point out that Anjali just said, which is totally true and 100% correct, is that they're very easy to add nodes to. Okay, they're very easy to add nodes to. So for example, so in the traditional array, you can't even adjust the size, but another thing to think about it is if we have this zero indexed array, right? So this is the list data structure in Python and how this would work under the hood. So going back to kind of that list that we had initially, Joe, Anjali, David, Melina, we don't even have to worry about the associated colors with them right now. So if we have here Joe, but we're going to keep the ordering important. Joe and Anjali, David, Joe, Melina. If somebody else comes in, which fortunately they did actually, and he even came in with a very good name for us. He entered with the name Inez. So if somebody enters with the name Inez, okay, Inez is going to need to get entered here because we want to keep our lists in alphabetical order. A couple of reasons. If I'm searching information, obviously, if I'm, just like in a library, a computer works the same way. If I have something organized by alphabetical order, it's going to be a whole lot easier to find it and say, yes, we have this, no, we don't have this, versus just having to like flip through every single book in the library and see whether we got it, right? So that's why having organized data is extremely important. And so we want to keep this in alphabetical order. So what I need to do, Inez has just entered the room. So I need to add her to this list. What do I do to keep this in alphabetical order? The first thing I kind of have to do, even manually, is scoot over Melina to the number 4, scoot over to Joe to number 3, add Inez to position 2. That's how that works. And that's actually how it works with a standard list also under the hood. So, for example, if I'm adding a new element to the beginning, to the middle of an array, it used to be the case that Joe's index and Melina's index, if I want to access this data in Python, I would say, you'll remember from this little thing that I just pulled up here. Remember this little page that we had for a hot second? I would say, if I say names 0, colors 0, I get Joe Blue. That's because these are not in alphabetical order. Let me actually fix that and make this alphabetical order. Okay, now my favorite color is green. So if I say name 0, color 0, then I get Anjali Blue. But if I change it and I say names 2, colors 2, I get Joe Green. Sounds good. Now, though, the point is under the hood, how this data structure works is under the hood, names sub 2 is tied to Joe, and name sub 3 is tied to Melina. So now, if I come over, if I'm back over here and we want to add Inez to the list, the first thing I have to do is make list or name sub or Melina tie to name sub 4. I have to make Joe tie to name sub 3, and only then can I add Inez up here. And of course, if it's Brian instead of Inez, then I have to also make David name sub 2 and Brian name sub 1, right? So this is called an O sub n operation. Okay. So let me pause here. I know you guys don't know what O sub n is. Not everybody knows what O sub n is. I'll explain that in just 1 minute, but I want to see if you guys understand the point that I'm making here so far?
Yeah, I understand that you gotta set it up so whenever the alphabetical order changes, I mean the name will match the alphabetical order that you want.
Right, and the point that I'm making is, and the point that I'm.
Does that mean that you need to put a link right after each of them?
So hold on. So let me make sure I'm taking a step back here and making sure this is clear. So this is O sub 1. So this is actually an O sub n operation. So this operation is this is not referring to a linked list right now. What I'm doing right now is I'm contrasting the array that you get in Python to a linked list. Okay, and what I'm doing is I'm going to insert, or what we have actually just done is inserted. I say array. I mean it's called a list in Python, but it's the data structure whose code I've showed you a couple times. It's bracket, and it's sorted data, right? So it doesn't even matter that it's sorted. It just matters that. Well, I guess it does matter that it's sorted. So we do the point is, if I want to add an element to the middle of this array, currently, in our initial list implementation, this element is at the 0th position, this element's at the 1st position, this element's at the 2nd position, this element's at the 3rd position. In order to get Brian to the 1st position, then I have to scoot all 3 of these over and then add Brian up here. So the point there is that's 4 operations. Okay, that's 4 operations, and I'll show what those are again. The 4 operations, these are 4 things that your computer has to do under the hood. It has to move Melina over to 4. It has to move Joe over to 4. It has to move David over to 4. And it has to insert Brian at 1. I said 4 a bunch of times, but I meant 4, 3, 2, and insert Brian at 1. Okay, so those are the operations your computer has to do if you're inserting a new element into just a list in Python. Okay, if you're using Python and you insert a list, or an element into the list, it looks easy for us, and of course it is easy, right? But you have to do essentially the number of elements that there are after the one you want to insert is the number you have to scoot over, right? So it's 4 operations to do this. And again, if this wasn't Anjali, Brian, David, Joe, and Melina, if this also had 5,000 names or 100,000 names, it could be anything, right? Then, and I want to insert the data at position 2, instead of it being 5 operations, it's 100,000 operations, right? So I have to scoot everybody over to insert this new, this person into position 2. Okay, does that broadly make sense before I compare it to the linked list? So I'm talking about here the standard array where we have what's called 0 indexing, where now by knowing the item's position in the array, that's how I access the item. Okay, does that make sense? Are there any questions on what I'm saying here?
No,
It makes sense.
Okay, David, does it make sense to you?
Yeah, it makes sense.
Okay, sounds good. And then we'll compare this to the linked list, and hopefully that'll become clear. So now in a linked list, how we mentioned this here. So again, how elements are like known in the standard array here. So they're identified by their position in the list. So they're identified by index sub 0 or index 0, index 1, index 2, index 3. So they're identified in that way. In the linked list, if we come back over to the linked list, which is here, they're identified by that next property. So basically, what I can't do, a disadvantage of the linked list, is I don't easily have a way to access Melina directly. In order to access Melina directly, I start at the 0th element of the array. It's kind of like starting at the top of a chain and kind of tracing down until I hit the chain that says Melina. So if I start here and I'm traversing this list, then eventually I hit Melina, that's good. But to traverse the list, actually here is where I have the 4 elements. Is here I have to traverse through 4 elements, okay? So here, at a linked list, to get to any element of the linked list, you start at the beginning, and because the positioning, or what is the word I'm looking for? Because the identification, I guess, of what the elements are is done through just kind of following each element. Like each element contains the link. That's why it's called a linked list. Each element in the list, each node in the list contains a link to the next element. And therefore, if I want to access Melina, I start at Anjali and kind of trace all the way through here. Okay, so that's actually a disadvantage. But now what I want to do is switch over to the advantage of adding an element to a linked list. So here what we said, in this one, what we said is we have to, because the Anjali's identified by 0 and David's identified by 1 and Joe's identified by 2 and Melina's identified by 3, in the standard list, I have to scoot them all over once and scoot up, insert the new element, okay? In a linked list, Anjali, can you remember what you would do to add a new element in a linked list?
I think I could just directly add it to the end of the list, probably.
Well, you could directly add it to the end of the list, but let's say you want to add it to the beginning of the list, right? We want our data to remain alphabetized. So we've got Brian. So here's our new our new data point is Brian. So we want it to remain in alphabetical order. So what would I do?
Oh shit! I think I forgot. I'm so sorry.
That's okay. No. So what you would do is all you have to do is, instead of scooting, so these elements, I don't have to scoot these elements, right? I don't have to scoot these 3 elements over. Instead, what I can do is I just say, hey, instead of this one pointing to that one, now it points here. And now this one, Brian, now points to this one, to David. So that's the point. So in order to add an element to a linked list, if I had 1,000 people after Melina, it doesn't even matter. It's so easy. I don't have to scoot anybody over. Instead, it doesn't even matter where they're I can actually just add a link from the first element, or from the element where it needs to get placed, the element before it. I take that next property. There was a break between there. This is how the link was originally structured, or the list was originally structured. It was structured as this node points to this next node. What I do is I just replace that link from the prior element to the new element we want to insert, and add in that old next node as my new next node. And now, boom, my list still continues unbroken. So it's really easy to add elements to this linked list. And again, I'm going to contrast that again to this one, where in order to, and again, we just have 5, but imagine if there was 1,000 or 10,000 or 100,000 or more. I have to scoot all of them over and then, have this up, because these are identified essentially with their numbering. These are identified with their numbering in the standard list in Python. And in the linked list, we can trace them essentially through the link to the next node. The link to the next node is contained inside of the node directly prior to it. So in order to add a new element, it's super easy. It's 2 operations always. Doesn't even matter where I need to add it. If I want to add it here, all I got to do is come over to David, the element before where I want to add it, change his link from Joe to Brian, and then in Brian, I point Brian's next element to Joe, what David used to point to. And it's that easy. Same thing, if I want to add it to almost the end of the list, I break the link that was pointing from Joe to Melina, and what I do is I have Joe point to Brian, and now Brian points to Melina. So that's the logic of the linked list. So the advantage is, again, we've seen an advantage is that, and I know this doesn't even involve any code yet, right? This is all just pictures, but this is like a theoretical data structure which we then build in code, and of course it works the same way in code as we expect it to work in real life. And so we trace this through. We can break this link and add it here. So let me pause here. So the advantage is it's very easy to add elements to the linked list. A disadvantage is, if I want to access, for example, Melina from the very beginning, here, assuming I kind of know her number, assuming I know that Melina is element 4, I can say access standard list sub element 4. If I want to access Melina, if I want to access this Melina data point, because it could have a bunch of information about her, right? It could have her age. Let's say she's 89 years old. Let's say her birthday is January 32nd, blah, blah, blah. And so we have all this information over here. Excuse me. And so this is all stored in Melina's information. I know her name's Melina, but I don't know anything else. I want to get her age and her birthday. So we want to access this information. And so what we need to do essentially is in order to access this point, unlike the standard array where these data points are accessible by index, I just plug in index, or I plug in list sub 4. Here, I actually have to start at the beginning, because in order to access the 4, the only one I really have access to is the 0th element. And so I start at the 0th element and I have to traverse the whole linked list. So there's disadvantages and advantages, and that's the kind of the point of data structures and algorithms. They help us think through, how to structure our data. Like what is it that's going to be important to us when we're creating our applications, or we're creating, writing our code? Is it important that somebody can very easily insert elements to anywhere in this array or into this, pattern of data? Is it very important that we are able to quickly access elements anywhere in the data structure? Blah, blah, blah. And so that's kind of the logic there. Any questions? Let me pause here, and then I'm going to have you guys actually do some coding.
So when you want to insert links, let's say for a big data, do you do it individually, or that's when you write the code to, of course, not individually, that's when you write the code to make it generic, right?
Right. So we're going to look at code to build a linked list together in just a minute. And you guys are hopefully going to be writing some of your own as well. So let me pull up this IDE again. Were you guys able to open that IDE? So let's start by creating a node. I'm going to challenge you. Who do I want to challenge? Let me challenge Anjali. So we're going to create a node. If this syntax is foreign to you, don't super worry about it. This is just creating this is creating an object in Python. How you create this is our class definition. So what a node is going to look like. So what is it, Anjali, that we said is going to be contained in a node? We said there's two things in a node. Can you remember what they are?
Yes, I think the names and then the color, right?
Okay, well, what I mean there is, so that's our specific example, but in a general linked list, I like that actually. Let's just do that. Let's do that. And so what is the second, what is the difference? How are things identified in a linked list? Like how do I identify what the next node is in a linked list? So we're gonna have two things here. We're gonna have self.data. The node has to contain two things. It has to contain the data that we're looking to actually kind of organize, and it has to contain a link to the next node. Okay, it has to contain a link to the next node. So every node, what this class definition does in Python using this syntax means I'm defining a type of object. That's what this class thing means. I could have a car that has, a brand, a color, a type, like is it an SUV, is it a sedan, blah, blah, blah. Whatever characteristics are relevant for whatever application we're building, right? So, for example, most of the time, it's not going to have. Most applications are just going to kind of assume that your car has four wheels, right? We don't really care, or we don't care if your wheel color is green, so there's not going to be information that we store in data. So we store the data points in our data that are actually relevant, right? So node, I know this is very abstract, and so it's, data structures are necessarily abstract. They're like they are like the foundation of theoretical computer science, essentially. But what we have here is we're saying the object that is type node will always contain two pieces of data. It will always contain some basic data, and like whatever data it is that we're looking to store. I could also do it in a way that's like name is name and color is color. So it can be whatever data that it is that we want to store in our linked list or in our list. And the other thing it does is it contains a link to the next node. So those are the two pieces of information that are going to be stored in every single node of a linked list, okay? And again, let's go back to our theoretical structure. So in our theoretical structure of a linked list, we see essentially exactly this structure. Every node, so these blue things represent nodes, they represent elements in our data structure, and each node contains some data. So in this example, the person, the name of the person, again, it could contain more data. It could contain their age, it could contain their birthday, blah, blah, blah. And then it also contains this actual link. That's why I kind of have this actually drawn out here with the arrow. It contains the link to the next element in the list, okay? So for example, in Python, the first one, we're gonna initialize it to none. We're going to initialize it to none because we're basically saying, when you first create a node, you don't know what follows it yet, right? And the reason for that is the idea is if we want to add a new node to the end of the list, like if we want to add a new node after Melina's next is initially what, Melina? What is your initial next? In this structure that we have here right now, what is the next of your node? Where does your node point? Okay, Anjali, do you know where does Melina's node, the last element in the list, where does it point right now?
End of the node. So that's basically null, right?
Exactly. It's not pointing anywhere. Exactly right. So Anjali's node is clearly pointing to David's, and David's node is clearly pointing to Joe, and Joe's node is clearly pointing to Brian, and Brian's node is clearly pointing to Melina, sorry. But Melina's node is not pointing anywhere. Of course, you can make a linked list circular, right? You could make it so that Melina's node points back to Anjali and it goes in a circle. Like that is possible, of course. I'm sure there's some applications of that. I can't think of any off the top of my head. But Melina's node's not pointing anywhere. It's the end of the list. And that's how we know we've reached the end of the list. There's nowhere else to look. You've reached the end. So, if you go down a hall and you run out of doors, you say, didn't find it. So that's the same idea here. So the initial situation, when you add a node, it's the last element of the list, presumably, or you have to specify it. So we can start with none. Okay. Then what we're going to do, I've pre-written a little bit of this, so let me see here. So the thing that we're going to do here is we're going to actually build a linked list. So we need two data types, or not data types. That's the wrong word. It's two classes, two types of objects in our program. This is object-oriented programming. So this is programming that essentially focuses around creating objects of particular types. So our linked list, we're going to have probably one linked list that's going to contain multiple nodes. It's going to contain one or more nodes, or zero, but presumably one. So, but when we first initialize this linked list, we are going to not have any. We're not going to have any elements in it, right? So I have a question this is for Anjali again. Why is this called self.head? Do you know why it's called head?
Because it's the top of, like, you're starting from the head, basically, like your top of your list.
Exactly right. So what we're doing is specifying this 0th node, right? Because this 0th node is the one that we care about. It's the one and then after that, the only thing that the list itself has to contain information about, like the linked list itself has to contain information about, is this 0th node. Because after that, the 0th node contains the information about what's the next node. And the next node contains information about what's the next node. And the next node contains the information about what the next node is, and blah, blah, blah. So the point is the linked list itself only has to be able to find the 0th node. And because then each node can link directly to the subsequent node. Okay, does that kind of make sense? Do I need to pause here? Is that halfway clear?
Is that where you're gonna write the general code? Is that what you're explaining?
I'm explaining, so I'm writing the code and I'm trying to explain why I'm writing it that way. So the linked list, so each node, so the nodes correspond to these blue things here, and each node needs to contain the data that we want to have in it, as well as the next property, which again is just going to be this bridge to the next node. Okay, it's going to tell us this is the next node we want to go to. Okay, and the linked list itself, because each node knows what the next node is, because Anjali knows that David's the next node, and David knows that Joe's the next node. Because of that, then the only node that the linked list itself has to know about is this 0th node, this head node. It's got to know Anjali's where I start, and then every node subsequent will know all the way to the end of the list. And the end of the list I'll know because it's none. It doesn't have a next node. There is a none next node. So that's kind of the logic there. So then when I actually translate that into code, and sorry, this is the part I had written thinking I was sharing my screen and you guys actually couldn't see it. So again, what I've done now is I defined two classes of objects. The first class of objects is the node, and the second class of object is the linked list itself. So our node contains the data that we just mentioned, as well as the link to the next node. And the linked list itself, the only piece of data it actually has to contain is where is that head node? Tell me where that head node is, and then and that's what we have. And I wrote node here, and I meant to write none. I think did I write node again? I'm pretty sure Python changed it on me. So is this halfway clear? I know if you haven't done object-oriented programming before, this code might seem kind of foreign, but basically we have two types of objects. We have node and a linked list. The linked list, the only piece of information when we create a linked list it needs to have is who is the head node, and then each node, as we've seen, will contain the information about each subsequent node or where to find each subsequent node. Okay, so that's why we have data and next for node.
That's clear.
Okay, sounds good. Good. I'm glad that's halfway clear. That's a miracle. I take it you've seen a bit of object-oriented programming before, because otherwise the first time you see object-oriented programming, you're like, what is going on? So
yeah, I know there has to be a correlate, and then the language has to be very specific.
Right. Absolutely. So if I wanted to, for example, in Python, by the way, the self doesn't have any meaning, essentially. It just means I'm referring to myself. Like, you don't even have to worry about it. You can almost just pretend it away. You can almost just pretend it away. But basically what it's saying is we're referring to this, I'm referring to myself, which seems kind of obvious. So, but you have to write it in Python.
So you can call it anything you want.
No. You have to call it self.
No? Oh, okay.
Yeah. You have to call it self. It's yeah. But yeah, you have to write it. So it doesn't. Don't. If you're like, what is that self? Like, don't kill yourself over it. Okay. So if we wanted to create a new node, right? So if I get some new data, what I'm going to do is I'm going to append some new data to my list. So what I'm going to do is I'll actually call this new node, I guess, and create a new node in Python, right? So I'm hoping you guys are kind of live coding with me. And then the question is, if there is no, actually, sorry, I'm writing that like JavaScript. If not self.head, right? Yes, that makes sense. Then self.head is equal to the new node. Okay, so what just happened here? Can anybody look at this code and explain to me what lines 10 through 13 are doing so far?
Yeah, I think I can explain it.
Okay.
So basically, we created a new node with the name, and then check like if list is empty, and then if not, then new node becomes the head.
Exactly. Exactly right. Yeah. So basically what we're doing here is we've created this linked list, right? We've created this linked list, which was the orange part. It's just this, the idea is it's a container for our data. And when we initially create it, it doesn't have a head element. There are 0 nodes in my linked list. There are 0 nodes in my linked list. And then I say, I want to add a node that, or what I want to do is I want to add some data to my linked list. That's what this is really doing, right? We're taking in data and creating the node ourselves inside of the list. We're taking in data. I'll say that again a little slower. We're taking in data and then creating the node ourselves inside of the list. So I get in, originally our linked list is empty, and then we add in Anjali. And so then I append, so I create a node for Anjali, and I say, if there is no head node yet in my linked list, and when we first initialize it, that is true. When we initialize the linked list, when we first spin up the linked list, that is true. We have no head node. So then we say this node is now the head node. So just like Anjali said, now we have specified what our first node is for the list. Otherwise, if we did already have nodes, and I would actually have to return here. I'm sorry about that. Otherwise, we're going to have to traverse through that list, just like we said. Let me think for just 1 second. Yeah, so current is current.next. And then, yes, that makes sense. So what we've done here is, assuming that, so we say, if our linked list is empty, then add this node to make this first node the head node. Okay. Otherwise, take the head node, get the head node. Because the reason we could have written else here. We don't need to write else because we have this return statement. So that's kind of the logic there. So there's no need to write the else, but it is the equivalent of an else because we'll never reach this code if we hit this return. Like return ends your function. So if we have elements in our linked list already, then start at the head node and search through to the end. That's what that while current.next, because when is current.next not true? Melina, can you remember when will current.next not be true, or when will it not exist, right? That's what this is, this syntax here in Python tests. So when will current.next not exist? For which node will current.next not exist?
For the last one.
For the last one. Very good. Excellent, Melina. So current.next will not exist for the last one, because that current.next is the link from each node to the next node. And so it won't exist for the last node because the last node doesn't have a link to a further node. So this says while current.next, while there is current.next, then we'll rename this current variable to be equal to the node that's actually at current.next. So that's good. And then once we finally have found the last node, this for loop ends, or this while loop ends, when there is no current.next, aka when current is equal to the last node of our list. And when that occurs, then, oops, I wrote new code again. Then make that new node be equal to the next of that very last node. So basically what we're doing in that case, and I'll switch and share my PowerPoint. This is what this append function does, is here we are going to say, okay, we traverse through the list. We start at head. Our current is here. Just if current.next, then current.next. So originally this is, let me do it this way. So originally when we start, this was current. Come on. Okay, we'll just leave it here. So this is current. And then if current.next, so if this bridge exists, then current equals current.next. Well, current.next is here. If current.next, then current is current.next. If current.next, then current is current.next. If current.next, then current is current.next. Okay, here, finally, there is no .next because there is no bridge coming off of this node here. So then when we insert our node, like we said current.next is new node. We'd actually already created, this should already be sitting to the side. Let me create another node here. This was, even when we started this process, we had another node. We'll call it, I don't care. What is the name? Sarah. I was like, God, I can't think of a name. So we've created this node, and the next is none, as we saw. So then we said, okay, now have this next point to our node. And that's exactly, so now this is how you append an item to a linked list. We've appended Sarah to the end of our linked list because we created a node for Sarah, and then we built a bridge from the last node to Sarah. Okay, so that's the logic there. And that's what we did here. I will share this code after if you guys want to take a look. Okay, and then finally, you know what, for the code, let me leave it here. I was thinking about adding in this logic of adding an element to the middle of the list, like code to add an element to the middle of the list. So this would be the Brian example where you traverse the list. You traverse the list and break the connection from Joe, build it over to Brian, and then create a new connection from Brian up to Melina. But I think for what we're gonna do right now, we're gonna leave this because I think this was challenging enough. And if you understand these two concepts, then if you understand the theoretical concept and you're able to handle this object-oriented code to the point where you understand how the appending works, then you're in a pretty solid position. And what I would do if this were a university class, and I'm actually going to give you guys this option. I'm going to say this. If you guys want to go ahead and try and write that code for and add a node to the center of the list or a given position, add it to the third element or after Joe or something like that, then shoot me an email. My email is joe@passionclass.co. It rhymes. There's no M at the end of co. So it's joe@passionclass.co. And I will take a look and get back to you. So let's actually just look at what this, again, I don't know if this matters or not, but basically if we create a new linked list here, if we create our linked list, thank you. And we add in, how did I do this? I actually added in name and color. I never used color. Let me get rid of color. Oh, actually I can have name and color. That'll work. Data. So I need here name and color again. And then we can create node of name and color. Yeah, perfect. So if I say Anjali's favorite color is green, so now we've created a new linked list. Sorry about that. I've created a linked list with no nodes. I need to create a node. So then I append a node for Anjali. We create an empty linked list, and then we append a node for Anjali, and then we can append a node for David. David's favorite color is going to be blue. Apply blue. And then Melina's favorite color can be yellow. And Joe's favorite color can be purple. Current.next. Oops. Current.next is new node. Okay, let's give that a try again. Favorite color is not defined. Where did I write fave color? Okay, I think it's good now. And I'm going to use that display code that I had written. Perfect. Okay. So can you see my screen?
Yes.
Okay, perfect. So basically we can you can see kind of the linking structure. This is what this display does. It just prints out the linking structure here. You can see this first element, this first node, which is Anjali, links to the next node, which is David, which links to the next node, which is Melina, which links to the final node, which is Joe, or AKA, actually what it really does is Joe links to a none. So that's kind of the structure of our linked list. So, okay, I'm going to pause here. I welcome questions right now. This is your chance.
Honestly, I couldn't keep up up to 18, and then when I saw you pull back the Python, I was like, where do all those lists come from? But yeah, it's a bit complex. I'm just starting to learn Python. I mean, I'm still learning. I still have a few chapters left, but this kind of helps probably in the future too.
I hope. The thing is, so I do agree. This is challenging. So David, I also have. Let me see if I can pull it up for you. I also have a set of sessions for complete beginners. I don't know when the next one's scheduled, and actually, it may not be scheduled right now. And if it is not, then you should definitely join me for that. And I will make it worth your time. So let me start. Actually, let me even show you. If you want to come over here, an easier one I have right on here is the Passion Class, the website we're on right now. I have it for beginners. Let's see, programming for beginners. But let's try programming. This is the actual classes, but I do have that. Oh, where's the free class? I have a free pre-recorded class, free recorded session. That's what I'm looking for. Okay, well, this is good. This is learning HTML. I did that too. So I offer, I do a bunch of classes on intro to coding as well. So come check those out with me. If you want to leave me your email, I will send it to you. I will send you a link once that gets up. So that should be, and it's called coding. It's called your first programming class. So then it can, perfect, I got it. And if you also feel free to shoot me a reminder if you'd like. So that's one thing. I know this is definitely intermediate, at least intermediate level. Like this is like this is known for being difficult. This is known for being difficult. So no worries. And I appreciate your honesty. So what I will say is, following it even at kind of the, if you partially follow it at this hypothetical, theoretical level, the good news is data structures and algorithms is like the nightmare class for a lot of people, but it's also a class that, like, if you want to be like an analyst, it's the thinking that you gain in it that really helps you. Like, you're not going to remember, like, I had to refresh on linked lists myself, right? Like, you're not gonna, you're not gonna have it all in your head, but that the style of thinking that you learn from it is very beneficial as a software engineer. Because basically, when you're doing data analysis, you're gonna be looking through data and being like, okay, I've got all these numbers, like, what am I supposed to do with them? And it's kind of like, this thinking really does help you there. Okay, sounds good.
Yeah, I agree. I mean, a lot of critical thinking for this data analyst course I'm taking.
Yeah. Absolutely, as it should be. Good. Anjali, how are you doing?
Oh, this was great. I mean, honestly, I didn't have any expectation coming in. I was like, you know what? It's been a while. I just wanted to kind of learn this, just remember. And I was also kind of like applying for jobs at the moment because I just wanted to like switch my career because I work like really low level embedded systems at the moment. So it's like I'm kind of looking for that, and I just spend some of my time just studying myself, and it's kind of boring.
Right.
It's been a while. I haven't like gone to school and stuff, so it just kind of, but this is like such a refreshment, Joe. I really appreciate it. I think you did a really good job. Just helped me kind of like recall it everything, and okay, yeah, oh shit, I forgot, so those type of moments, and it's really good.
Good. I'm glad to hear it. I'm glad to hear it. And I know the code obviously gets technical quick. It's hard to avoid object-oriented programming when you're doing this, but then at the same time, like I hope the theoretical PowerPoint is somewhat helpful. So this was good. I'm glad. I appreciate it. Melina, how did it go for you?
Really good.
Good.
I really like the way that you explain things before you're writing the code on the PowerPoint. Because that part for me it's always been easier. For me, it's always been hard. The part where you actually write the code.
Yeah.
Like the lexical and the precise language, that you have to have it. That's what I usually get confused.
Of course.
Mm-hmm.
Okay, absolutely. No, perfect. So, well, good. I'm so glad and I appreciate it. Thank you for coming. If you guys want to share your emails, I should be able to get you a reminder. Again, you have my email, joe@passionclass.co. If you don't get it to me today, shoot me an email and I should be able to send you a reminder. But it should be however you found us. If it was directly on Passion Class, if it was Meetup, if it was Eventbrite, blah blah blah, it should be there.
Well, thank you. It was really interesting and very easy to understand.
Good, I appreciate it. Yeah, and David, keep it up. Come to my intro level classes, David. Check out my intro level classes too.
Yeah, I'll be on the lookout for that.
Okay.
Thank you.
Cool. Sounds good. Thank you guys so much. Great to meet you.
You too.
Yeah, Anjali's back. Anjali, we are just heading off. I said thank you so much for joining. I told David to join my intro level classes, and you should check them out too. Like, not an intro level, but I have other classes, for example, in this series.